there is one important aspect we have to discuss, and this is a management of API sessions. So, for instance, our user tries to open mobile application and log in with her username and password. That information is sent from mobile application to WebTrit backend, which then sends a request to establish a new session to BSS connector. And now we're assuming that API on the third-party VoIP system is such that it allows each end user to log in with his or her individual username and password and create an individual API session. This is the best method because all of the security is already there. We don't have to do a lot of things. So in this case, BSS connector sends a login request with username and password. If everything is fine, then this third-party system opens a new session, generates for it an access token, assigns expiration date, some other parameters, and that API token is returned to BSS connector. It's then stored in the WebTrit backend, and all of the subsequent requests, they continue using this API token which was generated. Unfortunately, many VoIP systems do not support this method. So if you have a system, there is just one administrator user account which has access to API, but individual users or extension of PBX, they don't have access to API. So in this case, we have to do a bit of additional work. So it starts the same. User tries to log in using username and password. This information is passed to BSS connector. But now, in order to log in to third-party API, it uses this master username and password, which is configured somewhere in the BSS connector settings. And it gets one master API token, which it uses for all requests for all the users. Now it has to find a user. So if Mary with extension 101 tries to log in, it tries to find is there an extension number 101. It compares the password and we assume that everything is fine. Now we still need to create that session information which WebTrit backend is going to be using. So in this case, a BSS connector is going to maintain the sessions on its side because again, this third-party system knows nothing about individual user sessions. And that's okay. So it will, on the side of BSS connector, it will generate session object, make up some access token, assign expiration date, and store that information locally. Session management, it provides a method to validate sessions. So when a user tries to connect, or when WebTrit backend on behalf of user tries to connect and update user information, it provides an access token. So the goal is to check whether that session is present, is still active, and if yes, return session information. And this method implements this. Refresh session. So if access token has expired, and usually access tokens are issued for a very short duration of time, maybe a few hours, maybe a day, and then after that period is over, access token expired, but we don't want to ask the user to re-log in frequently every day. They will be pretty annoyed by that. So during the initial authentication, a refresh token is issued. And the refresh token is valid for a long time, maybe for a year. So when this happens, WebTrit backend will try to obtain a new access token, refresh a session using refresh token. So again, your code does a validation and returns it. Here, this more code which is there, it just assumes there's some kind of a database adapter. By default, it's going to be in memory, but again, you can override it. You can provide your own class to have more permanent session storage. And finally, close session. When the user tries to log out, then we just delete the session information. And that's it. And the class OTP handler. So it just provides two methods. One to issue a new one-time password, another one to validate the code which user has entered. Seems to be easy enough.